Hi class, it's Bill Berry with a video in the Programming with Repetition series. This should be our last video here. And this is the video in which we were following up on one of the interesting things that we can do with loops that we didn't quite finish, and that was finding the smallest and largest, or minimum and maximum values. And so let's take a quick peek at that, and let's see what we can do. So first of all, close your eyes for a second. I want to read you a series of numbers. I'll show them on the slide in a minute, but just close your eyes. Your task here is I'm going to read this series of numbers, and I want you to tell me afterward what the biggest number was that was in the list. Are you ready? Eyes closed. 5, 18, 7, 32, 11, 31, 17, 4. Now, what was the largest number that you saw? I'll light these up on the slide. But without writing them down, without having to think, without having to worry about computers and programming and anything else, I bet you figured out that the largest number was 32. How did you do that? What you didn't have to do is write down the whole list of numbers. That wasn't necessary. What did you have to do? You only had to remember the largest number that you have seen so far. So when I said 5, you went, okay, 5 is the biggest number I've seen so far. It's the first one, must be. Then when I said 18, you went, 18's bigger, so now I have to remember 18. I don't care about the 5 anymore, right? You just have to think about the 18. I read you the 7, you go, don't care. 32, that's the biggest one I've seen so far. Then 11, nope, don't care. 31, close, don't care, and etc. So all you really had to do is remember the biggest number you have seen so far. And that's exactly what we're going to do when we write code for this. All right, so let's look at how we do this. If you're looking for the smallest value, or the minimum, you create a variable to hold that, but you assign it to, this is one approach, assign it to a huge value. That way, the first number that comes along has to be smaller than that, therefore it is the first, it becomes the smallest value right off the bat. Same thing if we're looking for the maximum, you assign it to a tiny or very large negative value, because that way the first number that comes along will therefore be the largest one you've seen so far, so that will occupy that spot right off the bat. So it seems counterintuitive at first, but if you're looking for min, assign it to a huge value. Looking for max, assign it to a tiny value. Then inside the loop, you check and see that whatever the number is that you're interested in is smaller than the minimum you'd seen before, and if so, you replace it. Right? You just replace the minimum and say, oh, this is the smallest one I've seen so far. Same thing if you're looking for max. You check the current value. If it's greater than the saved max from before, then you know that it's the new winner, right? It's the current winner, so therefore you replace that, and you just have to remember that one. So that's pretty easy, right? It actually is pretty easy in code, and this is what it might look like. So in this case, we're going to ask for a user's age, a friend's age. Let's say you're going to enter all your friends' ages, and you want to find the minimum and maximum of them. You use a sentinel. Again here, -99 will be your sentinel. Don't worry about that. It's not going to be confused with these guys. But here we set up a minimum. This is going to be our min count, our min value, and we set it to something huge. We create a max variable and we set it to something tiny, in this case a large negative number, which will obviously be way outside the range of a normal friend's age, right? So then inside the loop, all we have to do, got a little indentation issue here, all you have to do is inside the loop you say, hey, if the age that I just got from the user is smaller than the minimum I have seen so far, then I'm going to simply remember that, which means take the age and store it into the min variable. Same thing, separately, I'm going to check if the age that came through is greater than the max. If it is, right, if the age is greater than the max I've seen so far, then store that age in the max variable. Right? That's all you have to do, and then this is again priming the pump. You ask for the next stage, round and round, and notice here by using the priming the pump method or approach, we're not going to accidentally include the -99 in the min and max, right? Because if they enter -99, it's going to be here, and that's going to check. It's going to be -99. It's going to pop out of the loop. So this guarantees that the -99 doesn't pollute our minimum and maximum that we've been watching, right? So priming the pump again saves the day. way. So really convenient. Again, these are not extraordinary or strange kinds of technologies. It's just typical ways that you can use loops and some things that you can do that might be useful and typical in the programs that you care about. All right, so let me give you some hints because a lot of people have some trouble figuring out exactly how to implement these things. So let me give you a couple of hints and then we'll work through some pseudocode on an example before we wrap up. Here's Bill's hints for loops. First, write and test the code as if you're not doing any looping. So just write the code that works with one thing and don't worry about handling the many things. Then, to figure out where the loop needs to start, you start at the top of the code and you go down line by line and you say, does this line need to be repeated? Does this line need to be repeated, etc., until you find the exact point at which this line doesn't need to be repeated, but this one does. And if so, you know you have to sort of wedge the start of the loop between those two lines. You do the same thing starting from the bottom, looking for where code that needs to run after the loop, and again you'll find an exact spot where this line needs to be in the loop and this line doesn't, so you know where the loop needs to end. Then you just have to pick the appropriate type of loop because you know where it starts and ends. Now what type of loop do you need? Do you want a while? Do you want a for? What makes best sense? You then put it in place, and then sometimes you have to make some tiny adjustments based on that type of loop. For instance, if you then want a priming the pump kind of scenario, then you know you have to make some small adjustments to that. But that's really the key to sort of figuring out where to start and stop with a loop. Great. So let's look at another challenge, and while we won't code it unless you're in class with me, but we will code through the pseudocode so we can really talk through it. So here's a challenge. We're going to, let's say, keep track of a bunch of cars that are zooming by on I-90 east of Issaquah. The speed limit goes up to 70, not far from where I live, so we're kind of watching for speeders that are going more than 70 miles an hour. So we're going to let the officer, let's say, enter a bunch of speeds until he or she enters -99, which is going to be the sentinel to exit. So we kind of get the idea what we're going to do here. Now, each time you're going to ask for the speed of the car, and then you want to pop up a message to say, what is the thing that needs to be done with that speed? So if the speed was 70 or under, then no action needs to be taken. They're not a speeder. I suppose we could have, like, if under 50 miles an hour, there's probably a minimum limit, and that might be a different kind of problem that we're not handling here. But if it's over 70, but we're going to give a little grace space in here, right? We're going to say, look, if it's over 70 miles an hour, but it's not more than 5% over, then we're just going to give them a warning. We're still going to stop them, but we're going to give them a warning and say, hey, you got to stay within the speed limit. Now, don't go speeding and think that this is the way that law actually works. This is a made-up scenario, so don't speed and go over 70 and say, well, my instructor said. No, this is just for fun, right? Okay, so if they going more than 5%, right, if over whatever that is, then we're going to write them a ticket for real, right? And then after all the cars are entered, we want to tell how many cars were processed. All right, so this sounds like a fairly realistic kind of scenario. So the next thing we want to do is write some pseudocode. All right, so let me bring up our editor, because with pseudocode, the nice thing is we can use it to write pseudocode. I'll just make everything into comments, right? So that'll be fine. So what do we need to do here? Well, we know that we're going to ask the user for the speed, right? We know we want to ask the user for car speed. Right, so we know we want to do that. And then we might have the inkling that the next thing we want to do is to deal with the possibilities of the different scenarios, right? So what's the possible scenarios? If the car speed is less than or equal to 70 miles an hour, then what do we want to do? Then I'm going to indent and say, maybe display no action is needed. Great, perfect. What else? Well, we have 3 scenarios, so we actually are going to need at least 2 conditions to capture those. Usually 3 scenarios, 2 conditions. What else might we do? Well, otherwise, if the car speed is what? Less than or equal to 70, and then we need to add 5%. So I'm just going to do it by saying 1.05, right? Because 70 times 1.05 is 5% over 70. So if they are in that bucket, then I'm going to display the next thing, which is give a warning. Perfect. Now, we could put another else if, but we actually don't need to because there's only one other bucket that's interesting, and that can go in just plain else, right? Can go in just plain else. And that is if it's anything else, right? It must be greater than 70 and it must be greater than the 5% even. So therefore, we're going to display the final possibility, which is give or write a ticket, right? So there are our three scenarios. So that is a good start. So what is it that we have not yet handled? Let's go back to our problem and see what we've handled. Well, we haven't handled this case of multiple cars, and we also haven't had a way to process to say how many cars were processed, right? So we need to add those two pieces. So let's now go and figure out, let's get the count issue or idea started, and then we'll figure out what to do. So here, let's say we want to create a count, right? Set the car count to 0. Right? So we're going to set up a counter and set it to 0. When are we going to count? Well, we could do it one of two places, right? We can do it after we have gotten the speed from the user, or we could do it after this if block is finished. It doesn't make any difference that the car is in process anyway, right? It's being processed. I'm going to put it up here, but it doesn't really make that much difference. So I'm going to increment the car count, right? Doesn't matter, again, could be here, doesn't make any difference. It's going to be the same concept, right? So leave it either place. All right, so what else? Now we have this idea of the car count being incremented, and then somewhere we also know that we're going to have to display the car count and say how many cars were processed during this activity. So we've got this idea, then it's going to work. This pseudocode would turn into code and would work for exactly one car, right? You're setting the car count to 0, you're asking him for the speed, you're taking care of the right message based on the speed, and then you're incrementing the count. So for one car, this works just right? It displays 1. Now the next thing is to figure out the start and the end of the loop, right? So let's start at the top and see, does this line need to be repeated within the loop? Well, no, because if so, we're setting the car count to 0 each time. That means we're obliterating it. So that loop can't start here. How about this? Do you want to ask the user for the speed of the car more than once? Yeah, we've got to do that in the loop, right? So we know conceptually that the loop starts here, right? And we'll come back and make that fixed up in a minute, but you get that idea. Let's go find where the loop ends. Start at the bottom. Do you need to display the car count every time? Not really. We're only asked to display it really at the end. Do you need to increment the car count each time? Well, yes. If you don't increment it in the loop, then you're not going to have a proper count. So we actually know now that the loop ends here, right? So we know very specifically that that's what needs to be controlled with the loop. So I can simply go and indent all of these things. 1, 2, 3, 4. So let me go quickly do that for us, and I'll pause for a sec while I do that. Okay, I type fast, but not that fast. So anyway, there you go. So let's see now what we need to do. We know where the loop starts. We know where the loop ends. That means that when we write code, we know that the open curly brace goes here and the closed curly brace goes here. We don't really need this line in pseudocode because we don't write curly braces. Indentation is going to be enough. So let's just delete that. Okay, now next step is going to be, what kind of loop do we need here? Is this a while scenario or is this a for scenario? Well, this feels like a while scenario because we don't really know how many cars are going to go by. So we know that we probably are going to want some sort of while. Then we need to know a condition. So what is the condition? Well, based on our slide here, we know that they're going to enter -99 when it's time to leave. So we're going to say while the car speed is not equal to -99. That's going to be our loop. All right, that's our loop condition. Okay, so we now have our thing coming together pretty well. Our problem, our algorithm is coming together pretty well. The only problem that we're going to have now is the car speed is going to be, the -99 is going to be included, and we're going to get this extra message when they enter -99. It's going to say no action, right? We don't really want that, right? We really don't want that to happen. So we've got two choices. We either can solve this by creating another if statement, right? So if you're not quite thinking of all your options, you could do this, right? You could say if the car speed is not equal to negative 99, then, and then I move all these things over to be part of the loop. 1, 2, 3, 4, 1, 2, 3, 4, etc. Right? Because we don't want to increment the count either, right? So all that stuff would have to go in it. But this seems a little bit repetitive because we have the negative 99 here and we have the negative 99 here. If we change the sentinel, we're going to forget and we're going to have a bug because we're going to forget to change one. So we're not really remembering one other good option that we have. So let me quickly Control Z us all back to where we were before. Okay, so what is our other option? Well, the great option here, priming the pump, right? This is just such a useful thing. How does the priming the pump thing work? Well, we do exactly two things. We're going to take it out of here and we're going to put it right before the start of the loop. Priming the pump says ask the question right before the start of the loop, and it has one other really important piece, and that is what? Right before the end of the loop, ask again. Ask again, right? Now that has to be the last thing, right? It's always the last line of the loop. But priming the pump will mean that the negative 99 will never infect or pollute the data, will never run this code if they enter the negative 99. So now we're clean. We don't have to write silly if statements and duplicate the negative 99. Priming the pump actually saves the day here. Then after the loop, you display the car count. Done, right? Completely done. So let's jump back to slides and wrap up. So here's an example without the loop. Then determine where the loop needs to start and end. We walked through that and we figured out, looking line by line, what needs to repeat, what doesn't. So we knew the loop contents. Determine what type of loop makes best sense. We knew a while made the best sense, right? Then we realized that we had a problem if you test it with the negative 99, if you start writing the code. So we don't really want the no action message. So now, we have two options. We either have to write another if statement, which makes it feel kind of icky to me, right? It's duplicative and it feels a little bit icky. So we don't really like that maybe necessarily. Instead, we like the priming the pump version. And that really solves the problem very, very nicely. Again, this is a model that's so helpful in the future, and I really hope that you've taken that to heart and understood what it wants you to do, how it works, because it will solve a lot of problems for you. All right, so that brings us to the end. Sorry, this video got a little bit long, but that brings us to the end of all of our exploration of repetition. I encourage you to work through those problems, to code them up in JavaScript and make them work. If you have questions, then if you're in class with me, obviously you can bring them to class and we'll work through them. If not, thanks for watching the video. You can always post in comments below. Thanks for watching, and we'll see you in the next series.